It does not get faster than this. Yeah, this tiny PC with a 5090. I'm gonna be honest, I was not sure whether this would even work, but in the end, the temperatures turned out so good that I think this is gonna be my new machine. It is though far from simple. I mean, I needed to do some really unexpected things to get this to work. Now, of course, for the CPU, we're going with the Ryzen 9800X 3D. It's the fastest gaming CPU at the moment, and it's going to give us the least amount of bottlenecking possible for our GPU. And luckily for this build, it doesn't require much cooling at all. The 7800X 3D would also be fine here, but the 9800 just goes that extra little distance. In some games, there's no difference at all. In others, there's a pretty big uplift in performance. The board that I'm using here is the MSI B650i Edge, and yeah, you're probably sick of seeing me use this over and over again, but we do actually need a board with very low profile VRM heatsinks, and this one is perfect. A lot of other ITX AM5 boards on the market are seriously overbuilt, which means I wouldn't be able to use this CPU cooler. Couple of things we need to do before we get to that though. For the SSD, I'm using a 1TB 990 Pro M.2. If I end up making this my main machine, I'll add another 4TB or so for editing just on the back of the board, but for now this will be perfect as a boot drive. And then for the RAM, these are Trident Z modules, 32GB, 6400 MHz CL30, and I had to remove the heat spreaders. This will 100% void your warranty, but granted you do it safely, you won't have any issues. The maximum RAM height for what we're doing here is just 33mm, so yeah, either do this or find some modules you like without any heat spreaders to begin with. The Crucial Pro modules will also work fine here. Now we are lucky that the 9800X 3D doesn't pull that much power, but I still want to run as much cooling as I can, at least within the 47mm height limit, which is all we have to work with. But for that, the Alpenphone Blackridge is an absolute monster. Takes up quite a bit of space though and won't fit on most modern motherboards, but at just 47mm tall, this thing is a beast. It's cooled by a 92mm fan, which I swapped over to Noctua's model instead, and something else also worth doing here is adding a 2mm fan spacer between the fan and the heatsink. Because the heatsink fins are so close together on this cooler, it can actually create a really high-pitch airflow noise, so just creating a small gap for those fan blades here does improve that dramatically. I've tested this out in some previous builds and it made a massive difference. This CPU cooler though is not actually technically compatible with AM5 motherboards since it secures from the back of the board. Luckily though, there's something really cool that we can do here. First, we need to remove the CPU locking mechanism around the socket. You'll need a Torx T20H screw for this, which luckily was in my iFixit kit, and then just remove the massive socket backplate on the rear and replace it with this shorter one from Thermal Grizzly. Very cool that you can do this to make this work, but yeah, be very careful doing this because the CPU socket is completely open and can be damaged pretty easily. It's a pretty easy swap though, and now we can install our CPU and our CPU cooler. And this is where I found out I also had to remove the heatsink for our primary M.2. I usually run this integrated fan here at 0 RPM anyway, so there shouldn't be any issues with cooling. I will be the first to say though, this was a lot of work just to get our motherboard up and running, but man, is it worth it. We've ended up with such an insanely powerful and dense little package. Next up, we've got the case, and it's none other than the Formed T1. This thing will fit in most backpacks. It has an unbelievably optimized interior, and the build quality is on another level. For the most extreme ITX builds, I always find myself reaching for this one. The size, the proportions, the machining, it's just perfection. The best thing is though, is how flexible it is. You can actually adjust the clearance for your CPU and GPU on the inside. And for this build, I've actually offset the riser cable, which allows plenty of exhaust room for our GPU. The new 50 series Founders Edition cards have a really unique and super efficient way of exhausting heat straight through the heatsink. And without these offsets on the T1, you'd just be trapping hot air against the motherboard and the power supply. With this gap though, which is actually pretty generous. I'm hoping that we can make the 5090 work. You will need some additional M3 standoffs to make this work, but you can find them on Amazon pretty easily, and I'll list the specific standoff lengths that I've used here down below in the description for those interested. For the power supply, believe it or not, we now have 1000 watt, 80 plus platinum rated SFX power supplies. Not SFXL, but the true tiny SFX form factor. Completely blows my mind. This is the new Corsair SF1000, which just came out. Their timing on releasing this was perfect. Nvidia recommends a 1000 watt power supply as the minimum to run the 5090 safely. We could probably get away with a little bit less than that since the rest of our components don't pull that much power, but no point taking any chances. It does also come with a very neat 12-pin power connector for our GPU. And then lastly, we've got the RTX 5090. Aesthetically, it's a perfect match for the formed T1, just like the 4090 was, although this time it's a much easier fit. The 5090 drops in no problem at all thanks to it only being 2 slots in thickness, and the angled power connector also means that we don't need to use any special aftermarket custom cables. This is the stock one from the SF1000 and it works perfectly. After that, we just drop in our 2 fans and bolt those on, and the build is complete. I had to take a moment here to appreciate the density and optimization for this one. That 5090 is just framed so well in this case, but how does it perform? The first thing definitely worth mentioning is since we're using a PCIe Gen 5 GPU and motherboard, but then a Gen 4 riser cable in between, we do run into some issues. The PC booted completely fine, but then when I got to the desktop, I was getting a couple of blue screens, no games were opening, and I was getting some cursor glitching as well. All of this was fixed when I went into the BIOS and I forced the motherboard to also run at Gen 4 speeds. Then I went through, updated Windows, installed GPU drivers, enabled XMP, all of the usual stuff. It was time for the moment of truth. Can you actually run an RTX 5090 in a PC case this compact? The answer is only just. In Cyberpunk, with the 5090 pulling around 500 watts, the temps were almost at 80 degrees, with the room temperature at 23. That works out to be about a 5 to 6 degree increase over what I was seeing on an open test bench, which is about what I was expecting. But I found a way to lower the temps dramatically with basically no performance loss at all. If you open MSI Afterburner, lower the power limit on the 5090 to 75%, and then set an overclock of 250 MHz, you'll be running at far less power, but the same clock speeds as stock, with barely any performance drop at all. This forces the 5090 to run at lower voltages but at the same clock speed. Effectively, it's undervolting, and the efficiency gains are pretty insane. It's so simple and easy it sounds like it shouldn't work, but it actually does. Here in Cyberpunk, we drop roughly 80 watts, 7 degrees, we have a quieter fan speed with no performance drop at all. I ran through some more thorough benchmarks and yeah, it all checks out. A standard power limit is of course fine too, but you might as well set a core overclock while you're at it and reclaim back some of that performance. There was basically no performance drop at all in Cyberpunk and Forza Horizon, but in God of War Ragnarok, which pulls 550 watts plus, there was a difference. But I think a 4% drop in FPS for 120 watts less power draw is definitely worth it if you care about your machine running more efficiently, cooler, and quieter. I also had a closer look at the frame times in Cyberpunk just to double check that nothing weird was happening while we're bumping the 5090 against a power limit. But yeah, not spiky or anything. Same performance, but significantly more efficient. Since the GPU is running much cooler now, I saw some pretty decent drops in the memory temps as well, which now means in those games where you do see a 4 to 5% FPS drop, you can apply a memory overclock to get some of that performance back, whereas previously, maybe the memory temps would have been too high. I do also agree it is a bit of a weird concept to get a 5090, the fastest, most expensive GPU out there, and then start altering it in a way which might even slightly reduce the performance in a couple of games out there. Yeah, this build is not for everyone. It's more so just to see if the 5090 will work in this form factor for those who want to run it. And yeah, the answer is an overwhelming yes. The performance and the cooling on this thing was really surprising. I ended up running Cyberpunk for like 2 hours just to properly heat soak the system and see if it would just tip it over the edge, but after those few tweaks that I did, this thing became extremely impressive. I did also do a slight undervolt on the CPU just to help even more with the power and the temperatures there. I did a negative offset of -20 in the PBO2 section in the BIOS, and yeah, had the 9800X3D sitting in the mid to high 70s in Cyberpunk, which I think is pretty impressive with the tiny CPU cooler that we're running. This build is so impressive actually that I'm going to be swapping to it as my main gaming and editing machine. There are a couple more things I want to do just to make it a little bit more special, but I'll save those things for another video.